Algebra Unit 12, Lesson 3, Transformation of Functions, Notes and Video 3. A lot of these notes today you should find to be review of the past, kind of bringing it all together and hopefully solidifying your understanding of transformation or moving different parent functions or other functions that we can resemble parent functions and how they are manipulated. There are numerous ways to apply transformations to functions to create new functions. Transforming a function is to change its position or size. So change position would be reflect, rotate, or translate. Changing its size would be dilate. Consider the parent function f of x equals x squared. It can be modified with constants a, h, k, and k as follows. So parabola, the U-shaped graph, in standard form with our constants that change is f of x equals a times x minus h squared plus k. All right, the a indicates, and maybe you can fill this in like before I even say it, a indicates a something across the x-axis. Well, that would be a reflection. And or, so A, if it has a negative, indicates a reflection across the x-axis, and or it can also cause a vertical stretch. I'm going to change this, should be or a compression. All right then, so we talked about this multiple times, but a vertical stretch would be skinny and narrow, and a compression would be wide, short, and fat. So just two examples there. All right, these next pieces I'm hoping you can fill in again, because a lot of this is review. If a is greater than 1, the graph is blank. If a is greater than 0 but less than 1, the graph is blank. And if a is less than 0 or negative, the graph is blank. Take a moment and try to fill those in. Pause the video, and then I'll have your answers for you. All right, next one. H indicates a blank translation, and K indicates a blank translation. Again, I'm hoping you can do these two on your own from memory. If not, then just stay tuned on the video. But if you can, try to pause it and do them. So H indicates if we're translating or shifting left or right, or K lets us know if we're shifting or translating up or down. So let's do some of these examples. So describe the transformations that have taken place on the graph y equals x squared. Again, so that's our quadratic, that's our parabola. What is happening? We'll do A together. I'd like you to do B on your own. So now I'm going to kind of mention how many things you should have. A lot of us struggled on the quiz when we did this the first time. So we have a 1/2. Okay, we also have a 3, a -3, and we have a 7. So I should be talking about 3 things that have changed or happened here. So the 1/2 is less than 1 but greater than 0. So first thing, it's going to compress vertically. The -3 inside is minus h, so that tells us that this is moving to the right 3. And then the 7 is telling us it's shifting up 7. I'd like you to do B on your own. All right, we'll come back and do C together. Write an equation for the resulting function if the graph of y equals x squared has the following transformations. So this is the same thing as A and B, but in reverse. You give me the function, and I'm telling you what's happened. So again, I'm just going to start with y equals vertically stretched by a factor of 7. So that means I'm going to start with my A being 7. It doesn't say anything about reflection, so I don't need it to be negative, and translated down 3. So then I need my x squared, and down is the k, which is very last, and down means negative, so minus 7. All right, again, I'd like you to take a time out and do D on your own. So pause the video and do D. Next part, as we read on, the transformation rules can be applied to other parent functions, such as the following: the absolute value from the last lesson, and the square root function, which we're about to get into now. So the same A, H, and K remain. We're going to keep using them over and over and over to talk about how a parent function can be moved, shifted, or stretched or compressed, and how it affects it each time. Okay, on the back side, consider the parent function y equals the absolute value of x. It can be modified with constants a, h, and k as follows. F of x equals a times the absolute value of x minus h plus k. Describe the transformations for each function. So now notice in this, we're really not working with b, so don't scribble it out, but just make a line through it. We don't need to be concerned about b right now. Okay, so letter A. What is A? A is what's telling us to reflect or not, and if we need to stretch it or compress it. So in this case, it's -3. H is what's in the absolute value. It's telling us to move left or right, so that's a -2. Again, because our formula is x minus h. Since we have +2, it would be minus a negative. And k is -1. So now let's, in the next column, tell me what happens. So A made this, or the A negative part made it reflect, and the 3 made it stretch. I think I spelled stretch wrong. Nope, looked better the first time. Well, I hope that's right. The H, the -2, tells me that I'm shifting to the left 2. And the -1 tells me I'm shifting down 1. I'd like you to take your moment and do B on your own. And then we'll move down and do square root function. So pause the video and do B. Consider the parent function y equals the square root of x. It can be modified with constants a, h, and k as follows. Okay, so again, I don't need to worry about that b right now. So our parent function setting us up for transformations is a times the square root of x minus h plus k. Describe the transformations of each function. All right, we're going to start and do C together, and then again, I'd like you to do D on your own. So C f of x equals 3 times the square root of x plus 8. So again, the A is what's outside. In this case, our A is 3. And then the H is what's within the or underneath the radicand, or is a radicand. Underneath the radical is 8. And there's no shift up or down, so K technically is 0, and that's no shift. So the 3 again is telling us that we're stretching. There's no negative, so it's not reflecting, and the 8 is positive. Again, the formula is negative, so the only that could change would actually means H is -8, which means it is shifting to the left. Oops, left 8. So again, pause the video and try D on your own. And then we'll come back together for the last piece. Exponential functions are considered to be unique parent functions. Mathematical methods do not exist to transform an exponential function, but the techniques go beyond the scope for this course. For simplicity, we're going to assume that all exponential functions, such as the ones given below, to be unique parent functions. If an exponential function is represented in the form f of x equals a times b raised to the d times x minus h power plus k, such that d is a positive value, then. All right. So that's a lot. We're going to take it a little bit slow. All right, so first, if we have b is greater than 1, the function represents an exponential something. If b is greater than 0 but less than 1, it represents an exponential something. Again, I'm really hoping you can focus in and get these on your own. If b is greater than 1, it was a growth, and less than 1 but greater than 0 was decay. Again, I'm hoping that's memorized for us by now. So now if we just look these over, Here's a 2 and a 3 for B, so they're both growing. Here's a 1/2 and a 1/3 between 0 and 1, so they're both decaying. So starting small, getting really big quickly, starting big, getting really small quickly. Again, I'll review. Let's go down, so let's look at some. Describe the transformations of the following functions. Note that the parent graph of these functions is y equals 2 to the x. So we're going to be more simplistic in the ones I'm giving you. So the parent function for this problem, for these two problems, are going to be y equals 2 to the x power. And the transformed functions take the form, so this is our go-to, how do we know what to do, function. So this first one, a, the a is -1. Just remember there's a 1 there even though I don't see it. B is 2. H, again, is whatever is happening to the exponent or within the radicand or within the parentheses for a parabola. So that means h in this case is -3 and k is 5. And the asymptote is always going to be what k is. So y equals 5. The k tells me that I'm shifting up 5. The h tells me I'm moving left 3. The b tells me that this is growth. And the -1 tells me that this reflects. And the 1 would tell me if it was stretching or compressing, and 1 doesn't affect it, so that's all we need. Again, I'd like you to finish letter B on your own. Good luck.